All right, this is 2.25. So yesterday we looked at we looked at polynomial inequalities, and today we're going to do rational. So let's do the launch task together because we're going to need that for the notes. So this says, consider the function g of x equals 3x minus 1 over x plus 4 minus 2. It says, rewrite g of x as a simplified single fraction. So this is what we did earlier in the unit. So the common denominator is going to be x plus 4. So this is 3x minus 1 minus 2x minus 8. Be careful. You're going to multiply by the negative 2 and the positive 4. So be careful with that. So g of x is x minus 9 over x plus 4. All right, we're going to need that a little later. All right, this one I just have just a review. Do you remember? This is a rational function. And if I were to make a table, at 0 it's undefined. At 1 I get 1, then I get 1/2 and 1/3. Here I get negative 1, negative 1/2, negative 1/3. You have a vertical asymptote of x equals 0, a horizontal asymptote of y equals 0. So I'm going to use some different colors here. So that means the x-axis is my horizontal asymptote, and the y-axis is my vertical. So let me plot these. So I have 1, 1. And if you remember this, so it's going to hug the vertical and horizontal asymptote. So this is the parent function for rationals, okay? So this is going to help us as we move forward. To solve a rational inequality algebraically, you're going to set one side equal to 0. You do need to create a single fraction. You're going to find the critical numbers, which are the zeros, and any x value that makes the denominator 0. So those are critical numbers. And then we're going to use the test point method that we used before. All right. So in example A, it says, consider the function f of x equals 1 over x minus 2 plus 1. If I want to graph this, can you tell this one is right 2 and up 1? So what that means is my vertical asymptote is at x is 2, and my horizontal asymptote is at y equals 1. Then, since we know the general shape, all I do is I'm going to pick, let's say x is 3. Then that's 1 over 3 minus 2 plus 1, so that is 2. So then I know it does this, okay? And then I'm going to pick a value, let's say at 1. That's negative 1, plus 1, which is 0. So it's going to do this. So I can make like just a quick rough sketch there. All right, it says now write this as a single fraction. So the common denominator is x minus 2. So f of x is 1 plus x minus 2. So f of x is x minus 1 over x minus 2. Okay. So let's take a look. Look, this is what we have here is the equivalent graph to what we graphed. So where is the graph below 0? Well, the critical numbers are 1 and 2. So critical numbers are where you get the numerator is 0 and the denominator is 0. So the numerator can be 0, but the denominator cannot be 0. Then I'm going to do my test points. If I plug in 2, you'd get 2 minus 1. Or I don't want to plug in 2, sorry. It has to be to the right of 2, so let's try that again. That's 3 minus 1 over 3 minus 2. That's positive. What if I do, say, 1.5? So 1.5 minus 1 over 1.5 minus 2. So positive over a negative. Let's try 0. A negative over a negative is positive. So this would be bracket 1, comma 2. With a parenthesis. All right, any questions on that one? All right, so here we go. What you're going to do is you are going to get everything on one side. So I'm going to subtract the 2. And then I have to build a common denominator. So I multiply by the common denominator of x plus 4. Now be careful. You're going to distribute, so that's minus 2x minus 8 over x plus 4. You remember this was our launch problem. So that's x minus 9 over x plus 4. So my critical numbers are 9 and negative 4. The negative 4 is in the denominator. So denominator critical numbers are always open. And the top one is either open or closed depending on what you're given. So if I plug in 9, that's a plus. This is a minus, and this is a plus. So where is it greater than or equal to 0? That's negative infinity to negative 4 with a parenthesis, union, bracket, 9 to infinity. All right, the next one. We're going to add x and subtract 1. So I'm going to treat x minus 1 as a quantity, and then I'm going to be multiplying it by x minus 2 over x minus 2. So that's x minus 5 plus x squared minus 3x plus 2. That's going to be x squared minus 2x minus 3. So this is going to factor into x minus 3, x plus 1 over x minus 2. So then my critical numbers are 3, negative 1, and 2. Now this time, since I have the strictly less than, these are all open circles. Okay, these are all open circles. All right, so if I plug in 4, that's a plus. If I plug in, say, 2.5, that's a minus. This is a plus and a minus. So I'm looking for less than 0. So that's negative infinity to negative 1, union 2 to 3. At any point, pause and rewatch anything you need. Okay, now this one, it's already factored for me. So my critical numbers are 5 halves and 4. The problem, though, and negative 3, the domain of this is negative 3 to infinity. So when I make my number line, this actually starts at negative 3. It can be closed. The 5 halves is closed and the 4 is open. All right, so when you test, if I test 0, It's a 5, a square root 3, and a positive, so that's positive. I got negative, negative. So where is this less than or equal to 0? Well, I'm going to need the negative 3, union 5/2 bracket to 4, union 4 to infinity. All right, let's keep going. In example C, so we looked at this in the notes with 2.2. If I want to find the domain of a logarithm, I have to set the inside of the log strictly greater than 0. That factors. So my critical numbers are 6 and negative 3. Now remember, a logarithm cannot be negative. However, on this one, because I am squaring, it is possible to get negatives for x. These are going to be open. I get plus, minus, plus. So that's negative infinity to negative 3 with a parenthesis, 6 to infinity. All right, in a square root, you cannot have a negative under a square root. So I set this greater than or equal to 0. However, x cannot be plus or minus 1/2. You have to set 4x squared minus 1 equal to 0, okay? So if I factor my numerator and I factor my denominator, I have critical numbers of 0, 4, plus or minus 1/2. However, I have open circles here and closed here. Just because of time, this was plus, minus, plus, minus, plus. So my domain is negative infinity to 1/2 with a parenthesis, union 0 to 1/2 with a parenthesis, union bracket 4 to infinity. All right, those are the notes.